Today's class we will talk about practical circuits, mean we will talk about potentiometer. So first of all, let me show you one animation and then we will start working on potentiometer. So this is very simple example of potential divider. So you can see at this point potential voltage is 0, and if I move this one to the right, you can see potential is increasing with length of the wire. So at this end, this one is maximum. So from here simply we can say in this case V is directly proportional to L, or simply we can also figure out from here that V is equal to I times R, and from here we can say V is equal to I, and resistance, this is equal to rho L by A. As the resistivity of this wire and A is constant and current in the same wire is also constant, so simply we can write down V is equal to I times rho divided by A, and this one is constant, so we can take L out. So we can simply say V is equal to some constant times L. From here we can say V is directly proportional to L, means the voltage is directly proportional to L, or we can say the potential difference across this voltmeter, that is directly proportional to L. So this is one thing we need to understand from this very simple potential divider. Now let's move on to next one and try to understand more about potentiometer. I will explain you a little bit more about potentiometer. So this is very important thing, you need to understand this one. So you can take some notes of this. If it is clear to you, that's fine. If you have not clear, you can take some notes of this one. So this is very important one we will be using in our today's class. So I will clear this now. So let me ask you first of all, what is use of potentiometer? What is use of potentiometer? Potentiometer, so this is potentiometer. We can use this potentiometer first of all to find EMF. Potentiometer we can use to find EMF of any unknown cell EMF. So unknown cell EMF we can find with the help of potentiometer, we can find the EMF. The second thing what we can do with this one is we can compare the potential difference. So we can simply say it can be used for comparing PDs, means potential difference. We can compare with this. So these are two main uses of potentiometer. We can also measure potential difference of any component. If you don't have voltmeter, we can use potentiometer. We can measure potential difference across any component. So this is just introduction of potentiometer. Now this circuit is a potentiometer circuit. So in this case, first thing you need to understand, the cell connected here, this cell we call is a driver cell. So this one is driver cell, and the cell connected here with unknown EMF, this cell simply we can say this one is test cell. So we can determine the EMF of cell S. And also you need to notice in this case is the positive terminal of the driver cell. This one has to be connected with positive terminal of test cell. Otherwise this circuit will not work. And also you need to understand the use of this galvanometer. The use of galvanometer is that when the potential difference at this point, the potential at this point and potential at this point is the same. So the reading on this one will be equal to 0. It simply means that when potential difference across galvanometer is equal to 0, it means that there will be no current flow and the reading on this one will be 0. So then we will say this one is balanced. So we will say galvanometer is balanced. So this point is the balanced point. When V at this point and V at this point, they are the same. It means there is no potential difference across galvanometer. So we will say galvanometer is balanced. If this galvanometer is balanced, also we call this is null point. Null method we call this one. This method we call this is null method. So this is null method, means galvanometer reading is 0. So we can call null method. Also this point you can say this is a null point, means 0 point. Galvanometer reading will be at 0. So the 0 will be located at this point. So we also call this one is null point, means 0 point. Simply you can say galvanometer is balanced. Okay, so now we need to understand in this case, if we look at this wire now, So you see, this is a wire. This is high resistance wire. It is connected between A and B. If I connect voltmeter here, imagine that we connect voltmeter between A and Y. We can say this voltmeter is V1. Let's say this is V1. So we can connect voltmeter between A and Y. We can also connect one more voltmeter between A and B. So I can simply connect another voltmeter between A and B. So we can say this voltmeter is V2. Now we need to little bit understand about this one. So let's try to understand. In this case, this is V1. V1, if I need to write down V1, so I can simply write down V1 is equal to I times resistance of this part of the wire. So I can say resistance is A times Y. And current in the same wire, current is the same when this is balanced. There is same current in this part of the wire and also in this part of the wire. So we can also write down V2. V2 will be equal to I times resistance AB. Resistance AB means from this point to this point, the total resistance. Now in this case, we need to understand current is the same. So it means I is same. So we can simply write down here I is same. As I is the same, so we can say V1 over RAY. This one has to be equal to V2 over RAB. RAB. So I will be writing here now. So we will take V1 here and the resistance of part AY, we can say this is rho times LAY, or simply you can say AY, divided by cross-sectional area of the wire. And this one has to be equal to V2 divided by resistivity of the wire times the length of the wire, that is AB. And this one has to be divided by cross-sectional area of the wire. Now you can see here, you can see rho over A. This is common, so we can cancel this one in denominator. So we can cancel these two quantities. So we simply left with V1, and this is divided by LAY, and this is equal to V2 divided by LAB. Now here we need to understand one important point. That is the key concept you need to understand. Now if I look at V1, this is the V1. And this one is V2. This is the main point you need to understand. Can I say V1 is equal to EX? Because potential difference between these 2 points is the same as potential difference across terminals of this power supply. Means the EMF of the power supply, not the terminal potential difference. In this case, even it has internal resistance, it has no effect because no current is passing through this cell. So this is the EMF of the cell. So it means EMF of this cell is equal to potential difference between A and Y. So I can simply replace V1, then I can say V1 is equal to E times E sub X, and this is divided by LAY. And V2, as this power supply means this driver cell, it has no internal resistance. We are assuming this is the ideal one. So there is no internal resistance. So E naught in this case will be equal to V2. So we can replace V2 with E naught. So this is divided by LAB. And this one we will be using all the time. We will be using this one all the time. So you can take note of this one. And second thing you need to understand, if I need to find, for example, I want to find EMF of this cell, I can simply rearrange this one. I can say EX, this one will be equal to simply E naught times LAY divided by LAB. So we can find EMF of this cell. Unknown cell, you can say unknown EMF, means the test cell EMF you can find using this one. So very important result. Most of the time you will be using this one. So most of the time we will just use this one. But this is how you can find EX. Now also in this case we need to understand resistance of a wire. For example, resistance of this wire. I just want to emphasize on this point because we will be using this result in some problems. So you can see from here R is equal to rho L by A. So in this case, what is constant? For the wire, you can see constant is rho by A. This one is constant, and here we have L. So from here simply we can say in this case R is directly proportional to L. For the same wire, resistivity is the same, A is the same, so this is directly proportional to L. And also we have discussed that V is directly proportional to L as well. So this one here. So in here you have result 1, and here this one is the second one, and this is the third one. This is all what you need to understand about potentiometer. And also you need to understand the internal resistance of this test cell. It has no effect. It has internal resistance or it has no internal resistance. It has no effect because no current is passing through this one when this is balanced. And positive terminal has to be connected with positive terminal. And why current will be 0? Because when the potential on this side of the galvanometer and on this side is the same, it means no potential difference. So it means the reading on this voltmeter, this will be equal to 0. And this is what you need to understand about potentiometer. I hope you have better understanding of potentiometer now. So you can take some notes and then we start working on past paper questions. We will use these concepts and we will try to understand potentiometer by solving problems. Okay, so you can take some notes. You have few seconds and then we will go to next one. We will use these concepts, means we will apply. Okay, so please take some notes. If you have questions, you can ask me. Okay, so you can take some notes. If you have questions, you can speak out. If no questions, no need to speak out. We will go to past paper question. But these equations are very important. We will be using them all the time. Okay, let's move on to next. Okay, please look at this question and try to answer. You have 2 minutes. You can figure out answer by yourself. Then I will show you the answer and also explain. Okay, after 1 minute, I will show you the answer. Okay, so let me show you the answer, please. If you have got this answer, is wonderful. If not, you can follow my steps now and I will explain you how to answer this. So the answer for this one is B. Let's try to understand this one, how we can answer this problem. For this one, first thing you need to understand, a question is asking you to find Q and R, means the balance length between for Q and R. So this is the point Q and this point is Q and R. Yes, this one is R. But we have already discussed that between P and Q, resistance is 5 ohms and L is equal to this one. So we can write down in this case resistance of PQ, this is equal to 5.0 ohms. So this one we can write down. And the resistance of QR in this case is equal to 10.0 ohms. So simply we can say the resistance of QR, this one is equal to 2 times of resistance of PQ. And as resistance, this is directly proportional to L. It means that L for QR, it has to be equal to 2 times of L of PQ. So it means simply 2 times, we have 12.5 and we can get in this case 25.0 centimeters. So this is the answer. So it means this one is right. Now if we go to Q and S, so I will simply write down resistance of QS. This resistance QS. So we have point Q here and this point S is here. And this resistance, you can see this is 1525 and 5 times of this resistance. So we can say this resistance is 5 times of RQ, resistance of RQ. So simply now you can find out LQS. This one has to be equal to 5 times of this L, that is 12.5. So we will get this is 62.5 centimeters. Now we can go to next one, P and R. So here we have this is point P, this is point R, and this resistance is 15. So we can say the resistance of PR, this is equal to 3 times of resistance of QR, PQ, resistance of PQ. So it simply means that L for PR, it has to be equal to 3 times of L times PQ, means L sub PQ. So simply we can multiply with this and we can get our final answer. That one will be equal to 37.5 centimeters. So this is correct answer. So the answer for this question is B. I hope this is clear to you. If you have any questions, please, you can speak out. If you don't have questions, we just go to next one. So this is how you can approach these problems. You see what principle I have used, only this one. R is directly proportional to L, nothing else. Okay, I hope this is clear to you. Okay, So let's move on to next. If you have question, you can speak out. If not, we will just go to next. Another nice question on potentiometer. So please try to answer this one. First try by yourself. You have 2 minutes. Try to answer this. Okay, try to answer this, please. Takes time. Try to answer this question. First of all, by yourself. If you need any hint, you can also ask me. These are some very nice questions about potentiometer. If you can answer all of them with proper understanding, it means you have clear understanding of potentiometer. And any question about potentiometer, you can handle. Okay, after a few seconds, I will show you the answer. Okay, so let me show you the answer now. If you have done, it's wonderful. If you're still working, then you can follow my solution. Okay, so this one has to be the answer. This question is quite straightforward one because you see these two cells, they have the same EMF, so we can simply answer this question without solving or writing anything. We can answer just by looking at this one, because this one is 2 volts, so this one is 2 volts, this is also 2 volts, and this total resistance is 10, and this one is 100, so it means it has to be 40. Okay, so this is just by looking at this we can figure out. But let me explain to you step by step this one, how we can answer this one step by step. So the first thing we need to understand, if we can find the potential difference across this resistor, that will be the same potential difference as between these 2 points. So in order to find the potential difference, let's say I connect voltmeter V1 here, so I can simply say this is voltmeter V1, then it is connected between points P and R. So if I need to find the potential difference VPR, means between P and R, this potential difference simply you can find out taking this resistance divided by the total resistance of the circuit, that is equal to 6 plus 4, and multiplied by the EMF of the power supply, that is equal to 2. Now if we simplify this one, we will get that is equal to 0.8 volts. So this is the value of VPR, means the potential difference between P and R. This is how you can find out. This is one thing. Now, as in this case, VPR is equal to VQS. So I can just write down, if you have understanding, is wonderful. I'm just writing for each student to understand this one. Maybe some of you have very clear understanding, so you can listen this one. Still, you will get something from this explanation. At least you understand the problem solving method. So always there is something for everyone when I'm explaining. So it means VPR is equal to VQS. So it means that we can write down VQS divided by LQS. LQS. This one has to be equal to battery, this potential difference, or we can say potential difference between Q and T divided by LQT. So VQS we have found that is equal to 0.8. So we can write down this is 0.8, and LQS, this is what we need to find out. Means L we need to find. And VQT, there is no internal resistance, so it means this is 2.0, and this is divided by LQT, that is equal to 100 centimeters. So this is given to you here. So I can write down this is 100 centimeters. Now simply we can solve for LQS. LQS is equal to L, so our answer in this case will be 40 centimeters. So this is how you can approach this problem. So one thing you need to understand is that very important point, if it has internal resistance, for example this battery has internal resistance, then this VQT, this will not be equal to 2. So you will find VQT. So this is the potential difference across the wire, not always equal to EMF of power supply. If it has internal resistance, you have to consider that one. So you will take the terminal potential difference. If there is an other resistor connected here, you will consider the potential difference across that resistor as well. Means in a simple language, I can say this potential difference has to be the potential difference between these 2 points. If it is equal to this one, wonderful. If not, you need to find out. Okay, so this is the point. They will try to confuse you with these things. So you need to understand VQT is the potential difference between 2 ends of this wire, and then simply you can use this one and you can find anything they ask you to calculate. Okay, so I hope this is clear to you. If you have any questions, please you can speak out. If this is very clear to you, no need to speak out anything. I will just go to next. Okay, so it means it's time to go to next question. Very nice question. It is beautiful question on potentiometer. So please try to answer this now. Very nice question. It will test your understanding of potentiometer. Try. You have 2 minutes. Do it first of all by yourself. Okay, 1 minute more. Take time, do question, try to understand concepts, not just guessing. Okay, so let me show you the answer. If you have done, that is wonderful. If you're still working, you can follow me and you can see the solution. So this is the answer, please. If you have got this one, is wonderful. If not, let me explain to you how to approach this question without solving. One way to approach this problem is that because this is telling us that 1 by 4, it means this one you can divide into 4 parts. So I can divide this one into 2 resistors. I can take one resistor here. So I will take this one resistor. This is 90. This one is 90 ohms resistor. And this resistor, I can take this one is 30 ohms. So this is one way to answer this problem. This one is 30 ohms. And now I can connect voltmeter across these 2 different resistors. If I connect voltmeter across the upper resistor, let's say I connect voltmeter here, the reading on this one will be 9 volts. If I connect voltmeter here, reading on this one will be 9 volt. And the reading on this one will be 3 volts. So this one simply you can use potential divider formula, you can find out. So means in this case, if I say, let's say this is voltmeter V2, so I can simply say V2, this one will be equal to 30 divided by 90 plus 30, and this is multiplied by 12. So our answer will be in this case 3 volts. So we can find out value of V2. Now as this one is reading 0, it means the potential at this point, means at this point you can just assume after the second resistor, and potential at this point they are the same. So now we can connect voltmeter here. So we can connect voltmeter, let's say V3 across this one, and we can connect voltmeter across this one as well. So you can see in this case, this reading, you will say this has to be equal to 9 volts and this one has to be equal to 3 volts. This has to be 3 volts because this side is at 0 potential. So if potential here is 3 volt, here also 3 volt. So the potential difference has to be equal to 3 volts as well. So this one has to be 9 volts. Now we need to find out resistance of this one. So because they are connected, no current is passing here, no current is passing, and they are connected in series. So this is just a potential divider. So we can say current is the same. As current is the same, so we can say V3 divided by R. This one has to be equal to V4 divided by 150. So V3 is 3 volts and this is R, what we need to find out. And V4 is 9 and this is divided by 150. We can just look at this one, we can answer, but this is the way, in a systematic way, this is how you can answer. So this one is 3 times, we have 150 and this is divided by 9 and we can find the answer. So this one we can find out, final answer, that one will be equal to 50 ohms. So this is how we can approach. Simply you can divide this one into 2 different resistors, 9 volts and means 90 ohms and 30 ohms, because this is given to you 1/4. Means you divide into 4 parts and you take 1 part of that. That's meaning of 1 by 4. Means you divide this one into 4 parts, equal parts, and you take 1 part of that. That is 1/4. 1 out of 4. So the answer for this question is C. So any questions until now, please? Any questions until now? Look at this solution, please. If it is clear to you, wonderful. If you have any questions, you can speak out. So simply, now quick way to answer this problem. This is divided into 4 parts. This also has to be divided into 4 parts and 1/4 has to be here. So the 1/4 of this one, this is 3 parts. 1 part means 50 here. So we can answer. Okay, let's move on to next. Let's try to answer some more problems. Okay, please look at this and try to answer by yourself. You have 2 minutes. You can answer this one. If you finish before 2 minutes, you can speak out your answer. Otherwise, I will show you the answer and I will explain. Okay, 1 minute more. Still you have 1 minute. This is conceptual question. Okay, let me show you the answer now. Answer for this one has to be the EMF of cell 2 we need, means E2 we need. So why we need E2? Why we don't need E1 and R? First thing we need to understand, question is asking us to calculate the potential difference per unit length of the wire XY. So this is our wire XY. So we have discussed about potentiometer that the ratio ratio between E2 divided by XT. This one has to be equal to the potential difference between X and Y. So we can say that potential difference is XY. You cannot say now that VXY is equal to E1 because there is another resistor is connected here. So we can say that is VXY and total length is XY. Because this, you see, meter rule is given to us. It means you can find with the help of meter rule, you can find XT, and with the help of meter rule, you can find out XY. So these two we can find from here. And if we have V2, then simply, so let me use different color. It simply means that, so I can find out VXY means the potential difference over length XY if I have value of E2. So I have EMF and I have the length, so I can find out potential difference per unit length. So simply I need to find out, in this case, E2, because XT I can measure. So I only need this value. So I will use different color. If I have only this value, I can answer this question. So that's the reason answer has to be B. Because if you have E1 is given to you, you also need the resistance of this one. You cannot figure out E1 because you also need to figure out this one. Then you can find the potential difference across this. So it means no use of E1. We need E1 and R. And if only R is given to you, you cannot figure out the potential difference across this because you need E1. So it also doesn't work. So this doesn't work. Resistance doesn't work. Resistance of wire XY. If resistance is given, you cannot figure out potential difference. Okay. So the answer for this one has to be B. So B is the answer. If you have only this value, L we can find with this meter rule. That's the reason they're showing this meter rule. So you need to understand why they're showing this meter. Means you can measure with the help of meter rule. You can find all these lengths. So the answer for this question is B. Okay. Any questions, please, until now? Okay. Okay. Let's go to next one. Maybe one more question, then class will be over. Let's try to answer this one. Maybe this is the last question for today's class. So please try to answer this one. Take some time and try to answer. You have 1 minute for this question only. 1 minute. After 1 minute, I will explain. Actually, this concept I explained you at the beginning of the class. So now we will practice this one by past paper question. I hope you will simply speak out the answer straightforward because I have explained to you the test cell. We no need to worry about test cell. We no need to worry about its small r, mean its internal resistance. So I will say this one is internal resistance. So it has internal resistance or it has no internal resistance. We can find EMF of this test cell. Internal resistance. So internal resistance we don't need, because when I0 means balance point, it is balanced galvanometer, it means no current flow. If no current flow, it means that EMF of this cell, EX, this will be equal to the terminal potential difference plus voltage lost, V lost. So let me write down in a different way, V lost. So to make it clear to you, V lost means I times R. If no current, it means EX is equal to VT. No current means this one will be equal to 0. So we no need to worry about internal resistance of test cell. If we use potentiometer method, means the null method, this we use, we don't need internal resistance. So it simply means that answer for this question should be B. So let's check answer. Question is asking you which one is not required. We don't need that one. So the answer is B for this question. Okay, so that's all for today's class. I hope you have some better understanding about potentiometer, and we have done some very nice question about potentiometer. If you have understanding of these questions, it means you have good understanding of this topic.